Hello, I'm Bokyung Lee from Dong University DTM Lab. The paper I will review is using generative pre-trained transformers for electricity price trend forecasting in the Spanish market. First, this is the bibliographic information for the paper. This paper analyzed how to derive context-specific trend forecast from professional news and expert report using the inference capabilities of large language models. The contents are the same as the structure of the paper. This is the information. The long-term price trend forecast of the electricity market is highly uncertain due to various factors such as geopolitics, climate, society, regulations, technology, and the economy. Previous time series forecasting approaches used to determine energy price have faced significant challenges during and after the COVID-19, demonstrating that forecasting models are unable to cope with such unexpected disruption. Therefore, this paper aims to help address these issues by studying the potential of LLM to help predict the development of electricity market. Next is the material and method. This paper presents two paradigms. In context learning, also called prompt engineering and prompt design, allow user to interact with the GPT model by providing context-specific instruction or query. By creating custom prompt, user can elect response that meet their specific needs, leveraging the pre-trained knowledge of the GPT model while adding a layer of domain specificity. At this point, iterative adjustments are necessary to achieve optional result. Fine-tuning represents a different level of customization where the pre-trained GPT model is adapted to perform specific tasks. Fine-tuning allows the model to run from additional data while retain its general language understanding capabilities, resulting in more sophisticated and specialized model that can provide nuanced, context-aware response in specific domain. Next is the discussion details. GPT calculated three variables for the content of each news article as follows. First, impact on electricity price quantifies the perceived influence of each news article on electricity price on a scale from 0 to 10. These help identify the potential effect of each news article on energy price, serving as a crucial factor in sentiment analysis using in predictive model. And direction of impact evaluate whether the news article potential affect price in an up, down, or none. Finally, impact period explore the temporal effect of the impact by categorizing it into past, short, mid, long, or none. This classification help determine when the expected price effects are likely to materialize, further improving the model's accuracy. By using these three variables, the ability to identify the effect of news text on energy price is quantified and enabling LLM to effectively perform sentiment analysis. First, let's discuss in-text discussion. GPT is trained using a dataset of 8 news examples that include the expected impact on price, time frame, and direction. Once trained, it analyzed all news articles regardless of their creation time. Through an iterative process of training, testing, and adjustment, the optional prompt is designed as follows. Based on the impact value at the time of news release, the average impact of the news is calculated over the short term and mid-long term. The values are then grouped by period to compute the average. Finally, the sign of the value determines whether the energy price increase and decrease. Next is the fine-tune discussion. First, we predict the impact period of each news article using in-context learning. Then we randomly sample 25 data points from each category to create a training dataset for fine-tuning. Next, we calculate the percentage change in energy price before and after the news release based on time series data from 2018 to 2023. At this stage, we apply the exponential decay model and Gaussian model, incorporating weight to reflect the decreasing influence of news over time. Finally, we generated a dataset for each news article, including impact period, direction, and fast price change, and use this dataset to fine-tune the GPT model. In this study, the analysis was divided into short-term and mid-long term to calculate the average impact for each period and determine the direction. The accuracy of the prediction was then evaluated based on price variation after the news occurred. To measure the accuracy of the impact prediction direction, 3 types of custom metrics were defined. If the direction is up, open price must be lower than at last one of the close price value in the current or the next two intervals. Additionally, open price must be lower than at last one of the high price value in the current of the next two intervals. If the direction is down, the condition is reversed. Furthermore, for the news to be considered impactful, the price difference must be at least 2% for short-term analysis and 5% for mid-long-term analysis. The evaluation was conducted using accuracy and MCC and compared with the result of Vader and Bart. After reviewing the short-term analysis result for our model, the fine-tuned GPT model was found to be the most effective across various metrics. In particular, its consistently high accuracy and MCC score compared to the Vader and Bart model indicates that it can better balance true positive and true negative, which are crucial for sentiment analysis. In the mid-long-term analysis, the fine-tuned GPT model achieved similar or higher accuracy and MCC compared to other models. This indicates its ability to better balance true positive and true negatives. Next is the discussion. The short-term and mid-long-term analysis results show that fine-tuned GPT model tailored to specific tasks and domain outperform state-of-the-art sentiment analysis method. By leveraging the in-context learning approach, LLMs can enhance input and improve accuracy without modifying their parameter by integrating internal knowledge repositories. This approach is not dependent on a specific LLM model, making it a practical and cost-effective solution with a lower barrier to entry. However, for more advanced professional application, it is necessary to establish automated workflows to improve scalability and response accuracy. To address this study planned to develop a lag architecture. Finally, the conclusion. This study developed a new approach utilizing GPT model to generate price trend variable based on news and specialized text analysis. This new approach can be utilized to build an innovative hybrid model that combines GPT's analytical result with domain-specific knowledge and real-time data to address the complexity of the electricity market. The research finding suggests that GPT models have significant potential to provide valuable insight in understanding mid-term price trend. The Region GPT demonstrates superior performance in predicting electricity price trend is its advanced language understanding capabilities, which enable it to capture subtle nuances and distinctions in specialized news and report.